big bowl of ice at the beginning of class, so I did that, yay. So we're talking today about energy. Does anyone want to tell me what energy is? Kristen? The ability to do work. Energy is the ability to do work. So here I am, I'm going to push my table. Oh, I'm getting tired, I'm exhausting myself. Am I doing any work? No, why not? The table is but I feel like I'm exerting all this energy to do it. I'm not? No? Okay, so doing work means what? The table has to be moving. You have to move a mass through a distance to do work. Okay, if the mass doesn't move any distance, you didn't do any work. Of course it did move like the tiniest bit, so maybe a tiny bit of work. But essentially, if your mass doesn't move, you're not doing work. That means you're not using energy, even though you feel tired like you are. Because the technical definition of energy is that you are doing work. Now we have two kinds of energy, right? Two big scale kinds of energy, and what are those?
Kinetic.
Kinetic energy, which would be?
Movement, mainly.
Okay, energy that's moving, energy in motion. What's an example?
I think like running would be an example.
Okay, because your mass is moving, so that's kinetic energy. How about that pen?
I guess that's considered kinetic because
Okay.
it moved a distance.
Right, while it's moving, it's got kinetic energy. How about the other kind?
Potential energy.
Potential energy, and what's that?
Energy at rest or stored energy.
Stored energy, energy at rest, both good. So you could have positional potential energy, right? This could fall, so it has the ability to do work if it starts to fall or if I drop it or something. In chemistry, the kind of potential energy that we're really interested in is the kind that's stored in chemical bonds, right? So pretty soon I'm going to start burning this indoors, which is really unsafe and you shouldn't do that. But that's what we've got, so you know. So this propane, right, is a hydrocarbon. It's carbon and hydrogen all bonded together. And within the chemical bonds between the carbons and between the carbon and hydrogen is energy that's stored. And when I burn it, it breaks the chemical bonds and that liberates energy.
Should we like shut the door so we don't
Yeah.
scare everyone in the hallway?
Yeah, no scaring people. Well, if we actually do something scary, we go outside. So we don't actually breathe super toxic stuff. So we've got potential energy in this fuel, and when we burn it, we liberate it, it becomes fire, kinetic energy. But potential energy is stored in chemical bonds. That's a key point for today. That's something you might want to write down. Potential energy, energy stored in chemical bonds. Right, there are bonds. I mean, if I burned up this table, I would liberate the energy stored in the bonds of the plastic, right? You can pretty well combust that if you try. But we won't, although I think someone tried really hard once. So, heat. We're going to talk a lot about heat today. We've got our lovely ice water. What is heat?
That you're not dumping on my head?
No. Heat. So what's happening here? What kind of heat is moving because of this ice bucket sitting here? Is heat going from the ice out or from the environment in? Because heat always moves how?
Hot to cold.
Hot to cold. So obviously the room is hotter than the ice bucket, so heat will always move from high heat to lower heat. So it's going to move from the environment into the ice. So heat is energy being transferred as a result of temperature differences, right? We have a temperature difference between the ice and the room, so heat moves from hot to cold, always. One thing you need to know for the test definitely is the first law of thermodynamics. Anyone know that? Joshua? No, your brother's Joshua?
My brother is Joshua.
Micah.
Micah, yes, correct.
I have you both, right? That's why I'm
Yes,
making
one
a
physical
mistake.
science and one
Right,
chemistry.
I'll make sure to call him Micah tonight in class.
All right. Do it as you wish. All right, so basically the first law of thermodynamics is energy cannot be destroyed or created.
Yes, but it can.
But it can change
Right.
into different forms.
Right, so how would I change, say, I've got potential energy here. I
That was
changed-
kinetic energy.
Okay, so I changed form. I have potential energy, it changes form to kinetic energy. When I have this potential energy, energy stored in the bonds of my fuel, I light it on fire, I'm changing its form, I'm combusting it. I'm causing it to go from stored energy to kinetic energy. And we'll do lots of energy transformations in this class this year. So the first law of thermodynamics, energy cannot be created or destroyed, it can only change form. Now that's not 100% true because nuclear energy does actually create energy because it destroys mass. So the kind of unified theory would say that the net sum of all matter and energy in the universe is constant. You can destroy mass and get energy, but we're not going to do that in here because nuclear explosions are always bad in the classroom. So don't worry. The first law of thermodynamics works perfectly for everything you'll ever do in my class because we will never create or destroy matter or energy or anything like that. Always bad. So how do we measure energy? What are our kind of units that we would use to measure energy?
Joule.
Joule. So this is our